So electrostatics is basically the study of charges at rest. In the properties of charges, we have uh, two types of charges, positive and negative. Positive charges can be protons, positrons, or cations. Negative charges can be anions. Unit of charge is coulomb. Smaller units are millicoulomb, nanocoulomb, and microcoulomb. Also, the 1 coulomb can be defined as 1 ampere current passing in 1 second. We know that like charges repel and unlike charges attract each other. Basic unit of charges, charge on an electron, that is 1.6 into 10 raised to minus 19 coulomb. You better remember this result. Then we have next property, quantization. Quantization comes from the word quanta, meaning packets. That once we have defined the basic unit of charge, then charges can only exist in multiple of this smaller unit. So any charge found in nature is integral multiple of E. So Q equals to NE. Then we have law of conservation of charge. That is for an isolated system, the net charge remains constant. If you do exchanges between the bodies, the net charge should remain constant. Then we did some problems on the possible charges on nature. Next, after studying charges, we want to understand how charges interact with each other. And we know that charges interact each other by applying forces on each other. For that, we have a single law for it that is known as the Coulomb's law. So Coulomb's law says that if there are two charges, Q1 and Q2, and if they are separated by a distance R, then these charges will apply force on each other. If they are like charges, they will repel each other. So the force will be away from each other. While if one of the charges is positive, another is negative, so force will be towards each other. So Coulomb's law says that the magnitude of the force applied is proportional to the product of the charges and inversely proportional to the square of the distance. Combining this, we get a result that F is equal to K Q1 Q2 over R square, where K is a constant, proportionality constant, whose value is given as 9 into 10 raised to 9, and unit will be Newton meter square divided by Coulomb square. Its unit is Newton meter square divided by Coulomb square. And for some reasons that we'll be studying later, K is written as 1 by 4 pi epsilon naught. Pi is your that ratio, circumference by diameter. This is the ratio, circumference by diameter. And epsilon naught is a property of vacuum known as permittivity of free space. Permittivity of free space. So this is a Coulomb's law, and this is basically the scalar form of Coulomb's law. This is the scalar form of Coulomb's law. Any questions in here?
No, sir.
Okay. Here we like to write epsilon naught as 8.85 and 10 raised to minus 12. Unit will be Coulomb square per Newton meter square. This is epsilon naught, that is the permittivity of free space. So as I said, epsilon naught is property of a vacuum. It is some property of vacuum. So suppose experiments have been conducted. If this whole setup is submerged in a material or in a fluid which has a dielectric constant epsilon. Epsilon is the dielectric constant of medium, or no, we call epsilon as the permittivity of medium. So these charges are not now in vacuum, but in a substance, just filled the substance, or in a fluid, air, water, and any solid. And this substance or medium has permittivity epsilon. In that case, we modify our Coulomb's law and we write it as 1 by 4 pi epsilon into Q1 Q2 by R square. Instead of the taking property of the vacuum, that is epsilon naught, we were using epsilon naught. We are using epsilon. Here epsilon is permittivity of medium. We can write a ratio that is epsilon R, known as relative permittivity. Relative permittivity, that is written as absolute permittivity divided by absolute permittivity of medium divided by absolute permittivity of free space. That is vacuum. So this quantity is written as epsilon R. This is absolute permittivity of medium. So this is epsilon, and permittivity of free space, that is epsilon naught. From here, we can write epsilon is equal to epsilon R into epsilon naught. And then we can modify this formula. F will be equal to 1 by epsilon R, or 1 by 4 pi epsilon R into epsilon naught into Q1 Q2 by R squared. We can separate epsilon R, and this will be 1 by 4 pi epsilon naught Q1 Q2 by R squared. So this gives you that force in a medium is equal to force in vacuum divided by epsilon R. Let me write this as force in medium, force in medium, force in medium. Force in medium is force in vacuum divided by epsilon R. Absolute permittivity is same as permittivity. So we can either write it like this or like this. Any questions over this?
No, sir.
Okay. Do tell if I'm going too fast. This is your 11th standard syllabus. So if you feel like I'm going too fast, then please tell that I should slow down. Okay. So this is your Coulomb's law. The relative permittivity is sometimes called dielectric constant. It is also called dielectric constant. So dielectric constant, it filters down some of the electric field. How it does that, we'll be studying later in the conductor chapter. For now, this is how it affects the forces. So in other words, I can also write that epsilon R, that is your dielectric constant, is basically the ratio of force in medium divided by force in vacuum. Electrostatic force in medium divided by electrostatic force in medium. Medium divided by vacuum. So this is how dielectric constant can be measured. And for different substances like water, air, dielectric constant has different values. Any questions? Okay. Let us do a problem. So force between two charges is 100 Newton in vacuum. To find the dielectric constant if force between these two charges is reduced to 20 Newton if they are submerged in a fluid, keeping the distance between them constant. Find the dielectric constant of the fluid.
For 0.2.
Okay, see, first thing here, force in medium is force in vacuum by epsilon r. So we have to write this formula, epsilon r, as force in vacuum divided by force in medium, not force in medium by force in vacuum. It is force in vacuum divided by force in medium. Now calculate its value. Calculate it. 5. 5 is correct. Can you find the absolute permittivity of medium or permittivity of medium? That is epsilon. Epsilon is epsilon r into epsilon naught. And give me the value of epsilon naught as 8.85 into 10 raised to minus 12 coulomb squared per Newton meter square. Find the value of epsilon.
Sir, 44.25 into 10 raised to minus 2.
That is correct. So this will be the permittivity. After writing this, we can write vector form of Coulomb's law. So in the previous case, we were just writing the magnitude of the force. If suppose charges are placed in space, then how do we find the force between them along with its direction? For that, we'll take our xy axis and we'll use the concept of vectors. Suppose I have the first charge, which is placed at point A. Let us say the magnitude is q1. And this is the first vector, position vector of r1. So r1 vector, this will be called position vector of q1. Similarly, we have another charge q2, which is placed at, let us say, point B, and position vector is r2 vector. So r2 vector is position vector of q2. Now we have to write forces between these two. So I will call this vector as r21 vector. R21 vector is a vector directed from 1 towards 2. So I can write the force on charge particle 2 due to 1. This is F21 is force on Q2 due to Q1. Writing the magnitude, I have no issues. I can just write the magnitude like this. That is 1 by 4 pi epsilon naught into Q1, Q2, and distance between the charges will be r vector 21 mod of that whole square. But since this force is a vector, I need to write a direction. And I know this direction, this force will be directed along this r21 direction only. So to give this a direction, I will write r21 cap. The cap is a unit vector along r21. This is a unit vector along the r21 vector. So you know the unit vectors can be written like this. R cap 21. Unit vector is the vector divided by its magnitude. I can substitute it here and I'll get the value of force on charge 2 due to 1, force on Q2 due to Q1 as 1 by 4 pi epsilon naught Q1 Q2 divided by, instead of r cap 21, I can write r vector 21 divided by mod of r21 whole cube. Any questions up to here?
No, sir.
Okay. And another thing, from triangle law of addition, I can write r1 vector plus r21 vector. See, for going from O to A, then A to B. This will be equal to going from O to B directly. So this will be r2 vector. Or we can first write OA vector plus AB vector equals to OB vector. From here, I can write r21 vector is r2 vector minus r1 vector. I can substitute this also to get me a final result. that is F21 vector is 1 by 4 pi epsilon naught Q1 Q2. This will be R2 vector minus R1 vector divided by mod of R2 vector minus R1 vector whole Q. This is the force on charged particle 2 due to charged particle 1 in the vector form. Okay.
Yes.
Okay. Similarly, we can write force on charged particle 1 due to 2. This was force on charged particle 2 due to 1. So see, the magnitude is equal, but the direction is opposite. So we can write force on charged particle 1 due to 2, force on Q1 due to Q2. This can be written as negative of force of 2 due to 1. So if I write this, F of 1 due to 2, force on 1 due to 2, that is minus of force on 2 due to 1, that is minus of 1 by 4 pi epsilon naught Q1 Q2 R2 vector minus R1 vector whole divided by mod of R2 minus R1 vector whole Q. So to write the final result, this will be 1 by 4 pi epsilon naught Q1 Q2. Negative sign I can take in here, so it will become R1 vector minus R2 vector divided by changing the value inside the mod doesn't affect it. So this will just be R1 minus R2 vector whole Q. We'll take up a small problem on this. If you're noting it down, then complete noting it down. Then we'll solve a problem.
Yes.
Okay. Suppose we have two charges here. This is 1 millicoulomb, or let us say this is 2 millicoulomb charge, and another charge is 5 millicoulomb. Let me give this as 20 millicoulomb, 20 microcoulomb, and this as 50 microcoulomb. I'll write the position vectors of this, or the coordinates. For this, it is 1, 5, and for this it is 4, 2. So if this is charged particle A, this is charged particle B, then find force on A due to B and force on B due to A. So to do this, I'll just write force on B due to A. That will be equal to 1 by 4 pi epsilon naught Q1 Q2. That is QA into QB. And here formula will be position vector of B minus position vector of A. If this is VA, this will be also in order VA divided by this is suppose given in meters. So this will be R mod of RB vector minus mod of RA vector whole cube. So RB vector, it can be written as 4I cap plus 2J cap, of course in meters. And RA vector will be written as I cap plus 5J cap in meters. I'll putting down the values. 1 by 4 pi epsilon naught is 9 to 10 raised to 9. You can also write the unit Newton meter square per coulomb square. Q1, Q2, 20 into 50. But they are microcoulombs. And RB minus RA. RB minus RA will be 3I cap minus 3J cap divided by mod of 3I cap minus 3J cap whole cube. And this is a meter. This is meter cube. So meter cube will get cancel out meter square. Coulomb square will cancel out coulomb. And then this is 10 raised to 9, 10 raised to minus 6, 10 raised to minus 6, and 5 to 1,000. So that will give me 27 I cap minus J cap. This will be mod of 3I cap minus mod of 3J. This will be 3 root 2. So this will be 3 cube into 2 root 2. So this will come out to be 1 by 2 root 2 I cap minus J cap Newton. And if I want to calculate force on A due to B, that is just negative of force on B due to A. So that will be 1 by 2 root 2 J cap minus I cap Newton. So we can use this simple formula to find the Coulomb force in vector form. If you have doubt in any step, I can ask. If you want to be sure about the calculation, then please do the calculation by yourself. And if you have problems understanding the vectors, then you can tell me that this part I didn't understand, so I can explain. Okay, any doubts in this? Any questions?
No, sir.
Okay. After this comes the principle of superposition. So suppose there are two charges. One is call it negative. This charge is negative. and this charge is positive. So positive charge was attracting the negative charge by some force. Call it force on 1 due to 2 in this direction. Everything was going well, means the negative charge was being attracted by the positive charge. Now, after some time, what happened? Another charge came, Q3, another positive charge, Q3 came. And the charge Q3 is also now attracting charge Q1. So we have another force on charge 1 due to 3. Now, principle of superposition says that due to coming of this new charge, new force arises, but this new force does not affect the old force. That is, the new force does not affect the old force. In other way, the net force is here, net force will be sum of all the individual forces. The attraction between these two will not be affected by this new attractive force. The attraction between these two will not be affected by attraction between the new force. So we like to write it as net force is equal to sum of individual forces. So principle of superposition simply states that net force is the sum of individual forces. Net force is the sum of individual forces added vectorially, added as vectors. In another way, we can understand this as, suppose there is a charge Q1 and many charges are applying force on it. Let us say Q2 is applying force on it. This is force on 1 due to 2. Then Q3 is applying force on it. This is force on 1 due to 3. Then Q4 is applying force on it. Call it force on 1 due to 4. So we can write from principle of superposition that net force on charge 1 will be force on charge 1 due to 2 plus force on charge 1 due to 3 plus force on charge 1 due to 4. Likewise, the sum of the forces due to all the electrostatic forces. The forces do not affect each other. They are just vectorially added. Is this concept understood?
Yes.
Okay. Note this.
Yes.
Okay. Now we'll use this principle of superposition. Suppose I have a charge Q here, and let us say this charge is Q, and this charge is also Q. There is another charge, call it minus Q. This is negatively charged. The separation between these two charges is R, and these two charges is also R. Question is, find net force on minus Q. Find net force on minus Q. The minus Q has two forces over it, F1 and F2. Find the F1 and F2, that is forced due to individual charges, and then just add it. You'll get the net charge, net force. Can we get this answer?
So minus 11.25 into 10 raised to 9.
We don't need to put the values because all the other charges and distance values not given. I can just keep it in this term. Okay. Any questions?
No, sir.
Okay. I'll give you some questions to practice. So let us say you have a plus Q charge here, plus Q charge here, and you are keeping a minus Q charge at the center. This distance is A, this distance is A. Find net force on minus Q. Next, suppose we have plus 4Q charge here and plus Q charge here, and they're separated by a distance of 3A. I want to put another charge plus Q such that it is at distance x from A, x from 4Q. So find x in terms of A such that net force on plus Q is 0. So in this question, you have two forces, one on the left, one on the right. If this is x, then this you can write it as 3A minus x. And you can equate the net force to be 0 to find the value of x.
Yes, sir.
I'll give these questions to practice as homework. Once you are done, you can send me the answer. Let us say this charge is plus 4Q. This charge is plus Q. They are separated by a distance A. You want to put another charge. Let me say that this charge is negative. You want to put another charge Q here, x distance away from it, such that force on plus Q is 0. The question is find x in terms of A such that net force on plus Q is 0. These will be the questions that you will be doing. And send me the solution once, send me the answers once you are done.